Have you ever wondered what actually makes your computer think? When you open a browser, play a game, or even just move your mouse, something deep inside your device is working at incredible speed to make it all happen. That something is the CPU, the central processing unit, and it's often called the brain of your computer. But what does that really mean? And how does this tiny chip control everything? Let's break it down in a way that's easy to understand. The CPU is the main processor found in almost every computing device: your desktop, laptop, smartphone, tablet, smartwatch, and even many smart home gadgets. Physically, it is a small square of silicon, usually only a few centimeters across, protected by a metal or ceramic package. Inside that tiny space sit billions of microscopic transistors. These transistors act like extremely fast on-off switches. By turning on and off in precise patterns, they represent the ones and zeros of binary code, the only language a computer truly understands. Just as your biological brain receives information from your senses, processes it, and decides what action to take next, the CPU receives instructions from software, processes those instructions, and tells the rest of the computer what to do. Without a working CPU, your computer would be little more than a collection of expensive parts that cannot perform any useful task. The CPU is the component that turns electricity and data into actual computation. At the heart of every CPU is a simple but powerful process called the fetch-decode-execute cycle. This cycle repeats over and over, billions of times every second, from the moment you turn the computer on until you shut it down. The CPU first reaches out to the computer's main memory RAM and pulls the next instruction it needs to work on. You can think of this like opening a cookbook and reading the next step in a recipe. A special register called the program counter keeps track of which instruction comes next. Once the instruction has been fetched, the CPU must figure out exactly what it means. Is it supposed to add two numbers together? Move a piece of data from one location to another? Compare two values and decide what to do next? The control unit inside the CPU translates the binary instruction into a set of electrical signals that the rest of the chip can understand and act upon. This is where the actual work happens. The CPU carries out the instruction, performing a calculation, moving data, or making a decision, and then stores the result in the appropriate place. As soon as one instruction is finished, the CPU immediately begins the cycle again with the next one. Because this loop happens at such an enormous speed, a modern CPU can complete billions of these cycles every second. That is why most actions on your computer feel nearly instantaneous, even when the machine is handling several complex tasks at once. A CPU is not a single simple component. It contains several specialized sections that work together in perfect coordination. This is the conductor of the orchestra. The control unit directs the flow of data and instructions, telling every other part of the CPU what to do and exactly when to do it. It manages the entire fetch-decode-execute process and keeps all the internal operations synchronized. The ALU is the calculator and decision maker of the CPU. It performs all the basic mathematical operations: addition, subtraction, multiplication, and division, as well as logical operations such as comparing two numbers or deciding whether a condition is true or false. Whenever your computer does any kind of math or makes a logical choice, the ALU is involved. Registers are tiny, ultra-fast storage locations built directly into the CPU. They hold the data and instructions the processor needs right at that moment. Because they are so close to the processing units and so small, data can be read from or written to registers far faster than from any other type of memory. Cache is a small amount of extremely high-speed memory located on or very near the CPU chip. It stores copies of frequently used data and instructions, so the processor does not have to constantly go out to the slower main system memory RAM. Modern CPUs usually have multiple levels of cache, L1, L2, and L3, with L1 being the smallest and fastest, and L3 being larger but still much quicker than regular RAM. These components work together seamlessly to allow the CPU to process information at extraordinary speeds. When people talk about how powerful or fast a CPU is, they usually refer to several key specifications. Measured in gigahertz, clock speed indicates how many cycles the CPU can complete per second. A processor running at 3.8 gigahertz can theoretically perform 3.8 billion cycles every second. Higher clock speeds generally mean faster performance, but architecture, efficiency, and the number of cores also play major roles. Early CPUs had only a single core, meaning they could focus on one main stream of instructions at a time. Modern processors contain multiple cores, commonly 4, 6, 8, 12, 16, or even more. Each core can independently handle its own set of instructions, allowing the CPU to work on several tasks simultaneously. This is why your computer can run a video call, play music, browse the web, and download a large file at the same time without becoming unresponsive. Many modern CPUs support a technology that allows each physical core to handle two threads of work at once. Intel calls this hyper-threading. AMD has a similar feature. This improves efficiency by keeping the core busier and reduces idle time. Larger and smarter cache memory generally means the CPU spends less time waiting for data, which improves overall responsiveness and performance in most real-world tasks. If you found this helpful, please like the video, subscribe for more clear on ordinary why, and leave a comment telling us which computer component you would like us to break down next.